Algebra 2, we're looking at lesson 8.9, and today we're going to solve log equations. We still are going to need to do a check, but I really want to point this out. If you have the log of A equals the log of B, then, I hope this is pretty obvious, the insides of those logs must be equal. And we still have to be careful. We have to make sure that we actually have a possible solution here. But let's take a look at example 1 together right now. We have a log equals a log. And it's only going to take a moment to just say, well, the insides of those logs would have to be equal if that is a true statement. And I'd subtract a 4. 4 minus 4 is 0. Then we divide by 4. 0 divided by 4 is 0. But here's our check. Really, what's wonderful is the log on the left, we don't have to be concerned with. It's always positive inside there. It's always a 4. It's this second log with the inside that we're concerned with. When we plug in our 0 here, 4 times 0 is just a 0. We get a 4. In fact, you could even see that the insides literally are equal. It checks. And that is our answer. Take a look at example 2. The problem is we don't have a log equaling a log. However, whenever you have a log plus a log, you may condense by multiplying the insides together. And we can distribute, and we'll get 2x plus 16. So here's where we have to look at the inside of this log, the inside of this other log, and realize that these insides must be equal. So if we subtract a 16, we'll have 2x is equal to negative 4. And then when we divide by 2, we'd get x is equal to negative 2. Now, it's at this point where we can wonder if we should actually throw this out and say it's no solution. We should do a check. But guys, I want to point something out. Yes, we're checking if x equals negative 2 works. It's possible that it does. You only have to check the inside of a log. The 2 and the 12 here, the insides there, they're always positive. We're just concerned with x plus 8. When I plug in that negative 2 plus 8 is actually a 6. It's greater than 0. It's positive, so it works. We'll have x equals negative 2. Let's take a look at number 3. And again, we've got this addition of our logs. So tell you what, we're going to multiply these insides together. And inside here, we're going to distribute. We'll have 3x plus 12. And what you really have here are the insides must be equal. So we can say, if we brought this back up here, 3x plus 12 would have to equal x. So I'm going to minus a 3x. Normally I get rid of the small x, but it's easier to do it this way because we already have a 12 here. And if I divide by negative 2, 12 divided by negative 2 is actually negative 6. And this is where we really have to be careful. It's very easy for us right now to say, I'm not going to do a check, because it appears that everything is always working out nice and easily. But please do look at what we're about to see here. X is equal to negative 6. I need to check if the insides of the log are positive. And guys, we're in trouble. Because when you plug in negative 6 into that x plus 4, you get negative 2. This fails. By the way, your other inside part would have just been x itself, and you'd immediately see that you're in trouble. There's no solution here. So it's not like our checks that we've been doing are unnecessary. They really are required. You can do all of your work correctly, and getting an answer, you might actually see that really there is no answer to the problem. There's one last one I'd like to do, and this one right here has been showing up with some regularity on Alex, and it wasn't in our notes. Guys, if you see log base 7 of x plus 1 minus log base 7 of 3, you may condense, but you're going to have to divide. And it's here, once you divide, where you can look inside your logs and say, you know what, these two things have to be equal. So I'll get x plus 1 all over 3, set that equal to x. And by the way, you could say that's also a fraction. It's really x over 1. And the reason why I'm pointing that out to you is that really we can cross multiply. 1 times x plus 1 is just x plus 1. And 3 times x is just 3x. So next I'm going to minus an x from both sides. And we'll have 1 is equal to 2x. And then x would equal 1/2. But of course we're going to have to do a check. You know, we don't know if this is really going to be enough. X equaling 1/2, I'm going to have to check the insides of these logs. So I'm going to check x plus 1. And the other log that I have to worry about is just x itself. This 3 right here is always positive, so I don't have to worry about it. 1/2 plus 1, it's really 1.5, 1.5. So that's good. And 1/2 itself, well, you know, that's greater than 1. So our answer works. And we'll have an answer of x equals 1/2.